Okay, so we have a polynomial here, and they're giving us the polynomial in factored form. X plus 1 times x minus 3 all squared. Okay, there are actually two distinct zeros here. There's one at -1, and there's one at +3. And if we looked at the factors from here, we would get -1. And from here, we would get +3. But there's a difference. This one's just a single factor. This one is a factor squared. So this 0 actually repeats, because if I wrote this in a little bit more expanded form, I would get x plus 1 times x minus 3 times x minus 3. Which means when I factored this down, I actually had two x-intercepts that occurred at 3. Okay, so although I have two distinct zeros, -1 and +3, one of them is repeated, and that would be 3. Okay, just reading down here, the graph of the function has two different x-intercepts. We see that the function has two real and distinct zeros. Do you guys remember the difference between real and distinct and real and equal from grade 11? So we talked in grade 11 about parabolas, and if I had a parabola that had two different x-intercepts, we called that real and distinct. But if I had a parabola that touched the x-axis and bounced back up, we would actually have two x-intercepts, and we call that real and equal. Okay, so the same thing kind of goes with polynomials. Okay, when the x-intercepts repeat, we call it real and equal, and when they're just separate, they're different numbers, we call that real and distinct. That's how both things are happening here. Okay, we have two distinct zeros, -1, +3, but we also have real and equal zeros at the +3. Now, when we talk about the zeros, we would say at -1, we have a multiplicity of 1. And at 3, we have a multiplicity of 2. And I'm just going to connect that for a second back to these factors. What is the degree on x plus 1? Or what's the exponent on the outside of it? 1. Okay, so the multiplicity of the x-intercept is related to what the exponent would be on that factor. So, just going back here, so the 0 of -1 is the 0 of multiplicity 1. Okay, whereas if we're looking at the x-intercept of 3, go back to its factors. Okay, x minus 3 all squared. What's the exponent? 2. The multiplicity is 2. So that introduces us to a few definitions: multiplicity, tangent, and point of inflection. So the multiplicity basically is how many times you're multiplying that factor. So if the exponent on that factor is just 1, multiplicity 1. If the exponent's 2, multiplicity 2. If the exponent's 3, multiplicity 3. Okay? And we're going to be looking at how it affects the shape of it. We're going to talk about that actually starting right now, looking at the definition of a tangent shape. Okay, so tangent is when you have a bounce. Okay, it's when the polynomial comes, it hits the x-axis, it doesn't cross it, it just hits it and bounces back up. Okay, and then you could have another scenario if you had a negative on the negative side. So it would be coming from below, it would hit the x-axis and then bounce back down. Okay, so it touches the x-axis, it does not cross it. We could call this tangent, and the multiplicity will be 2. And I'm just going to put in brackets or an even number, because later on in lesson 9 we're going to be looking at even multiplicities, which is also tangent, okay? But for this lesson, we can just go with tangent shapes, multiplicity 2. Okay, and so for example, what you would have is, say if you had a polynomial with x plus 4 and an exponent of 2, that would be multiplicity 2. And it would give this shape. Okay, it would just bounce off of the x-axis. The other type of shape we're going to see is called a point of inflection, and that's when we have a multiplicity of 3. Or odd number. So for example, if you ever had a polynomial where you had x minus 2 and the exponent was 3, okay, this would be telling us you have a multiplicity of 3. And if we have an odd multiplicity, like 3 or 5 or 7, what we have is a point of inflection. And point of inflection will have a change in direction on the x-axis. Okay, so notice here on the x-axis, if I look at the bottom shape of this, it's concaving down, it's curving down. Okay, and then as I change over, as I cross through the x-axis, it now concaves up. So it's a change of concavity. Or vice versa, it could be concave up and then switch to concave down in the other direction. So whenever we have multiplicity of 3, you will have a point inflection. And whenever we have multiplicity of 2, we will have a tangent. Okay, there's one other shape, multiplicity 1, and we'll go through that in this next example. So for starters, let's just graph the polynomial that they're giving us. So put that into your y equals. And you can decide whether you want to plug all of these terms in or if you want to enter it in its factored form. That's up to you.
Oh my goodness. Definitely not doing it.
So personally, I'm going to do the factors as well.
That just makes no sense. Just saves you a lot of time.
X plus 3 times x plus 1 squared
That makes sense. You're on fire almost.
times x minus 2 all cubed.
I'm sorry.
Now, this specific question is giving us some awesome window settings that's going to give us an awesome graph. So maybe if you ever see a question that gives you the window settings, take its advice because you'll get a better picture. So let's go to our window settings. We're going to go -5 to 5 with scale of 1, and our y min will be -100. Max will be 100 and our scale is 20. Okay, that's a way better picture. Can you guys see your x-intercepts a little better? Now what's our shortcut to finding x-intercepts? Table of values. Okay. Let's just see if they go through the exact x-intercepts or if there's decimal.
-3.
We should have 3 zeros.
-1 and 2. That makes sense. Hope it all lines up now.
Okay, -3, -1, and 2. So we're going to place those into our table of values here. And it was -1. So let's just go back to the graph. Now there's 3 different shapes that we're seeing in this polynomial. Here we have a straight line. Here, if you have to flip the page, what is this shape where it touches the x-axis and bounces back? What do we call that? Tangent. And when it concaves down and then concaves up, point of inflection. Okay, if you have to flip back to remind yourself on those terms, that's okay. Whenever we have a straight, the multiplicity is going to be 1. Okay, let's just take a look at our factors again. We had x plus 3 times x plus 1 all squared plus x minus 2 cubed. Okay, out of those 3 factors, do you think it's going to be the first one, second one, or third one that has a straight line? The first. Okay, and what we're seeing here is that when we have a multiplicity of 1, we will have a straight line going through the x-axis. Okay, earlier I asked you guys a shortcut to finding the x-intercepts. Besides using the table of values, where could we have looked right away?
Right there.
Our factors, and we could have found our zeros from there. Perfect. Okay, so from x plus 1 all squared, we have exponent 2, so what's your multiplicity? 2. Okay, let's look what's happening when x equals negative 1. Hey, it's bouncing, so we call that tangent. And if you guys want to label that on your graph, just so you can have an example. Feel
Can I
free.
draw the graph?
Yeah, you gotta draw the graph.
Not too good at that.
So the first x-intercept at negative 3 was straight, the second one was tangent. And looking at the third factor, the exponent's 3. So what's the multiplicity? Yeah. Okay, and when the multiplicity is 3, what's the shape? What do we have when the multiplicity is 3? When it concaves down and then concaves up? Point of inflection, good. Okay guys, so looking back at the polynomial that we started with, what is the degree? 6, good. And what would be the sum of the multiplicities? 1 plus 2 plus 3, you get 6 again. Okay, so what we can summarize is that whatever the degree of the polynomial is, that will be the sum of the multiplicities. And just a little bonus here, if you're ever asked to find the maximum or minimum, so for example here they're wanting us to figure out what that minimum is, you would go second, trace, number 3, and then you'd have to go left bound, right bound, and guess on that. So just move your cursor over, you're going to go left of that minimum point, press enter, go right of it, press enter. And do you guys remember with parabolas, would our minimum be the x coordinate or the y coordinate? The y coordinate. Okay, so our minimum here is at negative 102.5. Is that what you got?
Yeah.
Okay, good. So just reviewing again, if we have a straight line, multiplicity 1. Okay, the exponent on the factor will be 1. If we have a tangent, it bounces off of the x-axis, multiplicity is 2. And if we have a point of inflection, it concaves down then up, and that's a multiplicity of 3. So I believe this is our final example. Okay, we have a polynomial. They're not giving us the factors this time, which means we have to find the x-intercepts. So let's graph our function again. Lots of graphing. We have x to the power of 4 plus 2x cubed minus 15x squared minus 32x and minus 16. So they give us a little advice about the window setting. Well, maybe we should take it then. Okay, go to negative 6 to 6. Negative 150 to 100 on the y. And scale of 20. So before we talk about the x-intercepts and figuring out what they look like, I just want to go to here. The degree of this polynomial is what? 4. So what will the sum of the multiplicities have to be?
4.
4. Okay, so whatever we get here has to add to 4. So let's just look, before we even find our x-intercept, what do you think this is showing? Is it a straight line or a point of inflection? Straight line, so what will be the multiplicity of this one? 1. Yeah, I'll just put that there for now. Okay, how about this back one? Is it straight or is it a point of inflection? Straight. So that one's also 1. Okay, and what's happening to the middle x-intercept? It's tangent. It's bouncing off the x-axis, or multiplicity. Perfect. 2. So now we just have to figure out what are those zeros for those x-intercepts, for the multiplicity. So I'm pretty sure we can do this with our table of values. We have -4, -1. What's the last one? 4? Okay. Now we've already described it by talking about the graph, but just so you have the matching description, multiplicity 1, we saw a straight. Multiplicity 2, we saw it bounce off the x-axis, we call that tangent. And lastly, again, multiplicity 1, it was straight. So without going through the factor theorem and synthetic division, we can factor this. We have a polynomial. Okay, and from the first 0, with multiplicity 1, I will have a factor of x plus 4. And because the multiplicity is 1, my exponent will be 1. From the second 0, we have -1. The factor will be x plus 1. But the multiplicity is 2, so what's my exponent? 2. And lastly, we had a 0 at 4, so my factor will be x minus 4. Multiplicity 1, so my factor has a degree, or sorry, an exponent of 1. Now I'm just going to do a little dance that Mr. Moore used to do when he taught the course. So if you have even polynomials, the arms are always together. Okay, 2 arms together, they're even. Okay, now if going back to, I'm not actually going to do the dance. I think he had a song with it too. But he would, hey? Do you guys remember with polynomials, if your arms are up, whether the coefficient in front would be positive or negative? Positive and negative. Same thing goes for polynomial graphs. If both arms are up, the polynomial is going to be positive. Okay, and we can see that from the leading coefficient anyways. But if you get it in factored form and it's positive, and we have an even multiplicity, arms are up. If you have an odd multiplicity, okay, you're going to have opposite arms, or I guess I should say odd degree. So say you had x cubed there instead, you would have odd arms. They'd be opposite. And if you're negative slope, which will your left arm be? Okay, negative slope. Is it going to be up or down? Up. Okay, so you'd have negative slope this way, positive slope that way. So he did a whole dance. I'm not going to do it.